Assalamualaikum and welcome back to my video. Okay, so today I'm going to explain the example of 2.3. So here is the question. So the question states that a simple pendulum. Hold on. Okay. A simple pendulum with length 80 centimeter. Okay, so here please highlight the important information. So this is length, so that means this is the length of the string. So this is L. Okay, L is equal to 80 centimeter, or we change it as 0.8 meter. Okay, now it say that an bob of mass 50 gram. Okay, so this is the mass. So mass is represented as the m, which is equal to 50 gram, or 0.05 kilogram. Okay, is released when it makes an angle of 80 degree to the vertical. Okay, label angle of 80 degree to the vertical, okay. And then it says that it's released. Release means that it is started from 0 at the time 0. Okay, at the time 0. Okay, at time 0 equal to 0. Okay, there is when it says that it's released. Okay, it's released, there are two important information that you have to state. The first one is that the displacement, okay, the angular displacement at the time 0 is equal to theta max, or this is equal to maximum amplitude. Okay, and then the second is that the velocity at the time 0, which is theta single dot, at the time 0, okay, is equal to 0. Okay, this is the two information, the two important information when it says that released. Okay, released when it makes an angle of 80 degree to the vertical. Okay, now what does that angle of 80 degree to the vertical? So this is what it means. So let's say that we have a ceiling here, and we have the pendulum, which is connected to the bob. This is what we call bob. Okay, this is an equilibrium position, right? Equilibrium position, which says that theta is equal to 0, right? Because there is no angle. So when it says that it makes an angle of 80 degree to the vertical, it is either here or the other side. Okay, so right now I'm taking the right side lah. Okay, so here is the theta, which is equal to 80 degree. 80 degree to the vertical. Okay, this is vertical. This is 80 degree to the vertical. Okay, so here now let's look on the question. So the first one is that the question wants us to calculate the period. So when it comes to period, always relate to the omega. Okay, so when it comes to omega, as I said that in the video, there is 3 ways to calculate omega. So omega is equal to 2 pi over t. That's the first one. And the second one is omega is equal to square root of k over m. And the third one is omega is equal to square root of g over L. Okay, now here we have we have period, right? So I want you guys to substitute omega with either two of these. Okay, so right now in this equation, in this question, we have the L. Okay, we have the L, which is related to here. Okay, and then we have the m, the mass, right? The mass. So here we have the mass. But now, unfortunately, in this second equation, okay, we don't have the spring constant. And at the same time, when it comes to pendulum, okay, there is no spring. There is no spring, which means that there is no spring constant. But here in the third equation, we have the gravitational acceleration. So we have to substitute the third equation inside number 1, right? So here that we get that square root of G over L is equal to 2 pi over T. Alright, so T is equal to 2 pi times with square root of L over G. Okay, all you have to do is we have to put upside down. Okay, so here we can calculate the period. So T is equal to 2 pi multiply with square root of L. L is the length of the string, which is 0.8 meter. Always bear in mind that always change the unit. Change the unit into the main unit, which is meter. So 0.8 meter over the gravitational acceleration, which is stated that it is 9.81. So we get that period is equal to 1.79 seconds. Okay, that's the first equation. The first what's that called? The first answer to the first question. Okay. Now let's move on to the second question. So it said that you want to find the angular displacement at the function of time. What does that mean? That this question wants us to find theta x, theta t. Okay, theta t means that the angular displacement as a function of time. This is what it means. Okay, angular displacement as a function of time. This is what it means. So you want us to find equation for this system. All right. So we know that. Okay, let's move on. This is the B. Okay, so we know that theta t is equal to A sine omega t plus pi naught, or theta t, when it being derived, theta t means that A is equal to theta max, and then omega is equal to square root of G over L, right, times with the t plus pi naught. Alright, so here we can actually substitute theta max. We can substitute square root of G over L, which is omega. We can substitute that. But the problem is that we cannot substitute pi naught. We have to find this one. What is this? Okay, what is this? Okay.
We have to go.
Okay, now substitute first. Theta t is equal to theta max, which is equal to, what is theta max? Theta max. Okay, we don't know theta max, but don't worry. As I said that, this information is released when it makes an 80 angle of 80 degree to the vertical, right? Okay, please bear in mind that at the time 0 when it released, it is equal to theta max, which is an amplitude, right? So what is amplitude in here is that here, this is amplitude, this is maximum amplitude, or theta max. So what is the proof of this, that the 80 degree is the theta max? Okay, I'll show you an example. Yeah, right. So it said that in the simple pendulum, okay, here is the center, which is the equilibrium position. Okay, here is, as I said, this is the 80 degree, right? It's released when it is released when it makes an angle of 80 degree, right? Release when it makes an angle of 80 degrees. That means that this pendulum, okay, being pulled out, pulled up at 80 degrees and then release. So what happened that when it released, it will move back and forth, right? Forward and then backward. When it comes backward, it will move at the same position. It will stop at the same position. Okay, it will stop at the same position. Why? Because as I said, in this condition of the simple pendulum, the first one is said that the system is in frictionless. This is frictionless. That means that there is no air resistance. There is no any other external force is acted on the pendulum. Only that the system moves by itself. Okay, without non-stop. And the second one says that there is no energy dissipation. That means that this pendulum move. When this pendulum move, there is no loss of energy. It keeps moving until when? Until kiamat. Okay, sampai kiamat. Okay, it will move until kiamat. Dia tak akan berhenti benda ni sehingga kan there is an external force acted on this pendulum. So here is theta max. Okay, now on to this back on this question. So theta max, we know that it is equal to 80 degree, but here I want you guys to change that. Okay, this here, right here, we have to change into radian form, so 80 degree, okay, is equal to pi over 10 radian. Alright, now is equal to pi over 10, and then, oh sorry, this is sine. Okay, pi over 10 sine square root of g over L times with the t plus pi naught. So do we have square root of g over L? Yes, we do. Okay, so we have to find square root of g over L. So g over L is equal to omega. So omega is equal to square root of g, which is 9.81 over 0.8. In here we will get that it is equal to 3.5 per second. Alright, so substitute back. So theta t is equal to pi over 10 sine 3.5 t plus pi naught. Right, so now our problem here is to find pi naught. So pi naught here we can state that theta t, we can use t, we can substitute t as a 0. Why? Here, about the information that I have told you earlier. Here, at a time t equal to 0, theta 0 equal to theta max. So when we substitute t equal to 0, it is equal to theta max, right? Okay, which is theta max equal to pi over 10. So here, substitute back 0 inside this equation, so we will get that pi over 10 sine 3.5 times 0 plus pi naught. Okay, then we will get that pi over 10 sine pi naught. So here is equal to pi over 10, right? So pi over 10 sine pi naught is equal to pi over 10. Here we can cut off, here will become 1, here will become 1. So we get that sine pi naught is equal to 1. So pi naught is equal to, here since that we have the positive, so we will see that pi naught is at the location first quadrant or at the fourth quadrant. So that means when we sorry, not at the second, at the second, sorry about that. So you see that when you click the key in the calculator, we will get that pi naught is equal to pi over 2 radian. And unfortunately, pi over 2 radians is at the first and at the second quadrant at the same time. Okay, so that means that it has a high chance that pi naught is equal to pi over 2 radian. Alright, so it's okay. We lock first. Okay, we lock first. Okay. Now let's move on to the second condition. I say that theta that single dot, which is the velocity at the time 0, is equal to 0. Right? So this is the first. Now we'll move on to the second. Alright. Second, that I say that theta dot at the time 0 is equal to 0. Okay, so theta dot at the time t is equal to omega a cos omega t plus pi naught. Okay, we substitute that. So theta single dot at the time t is equal to omega is equal to 3.5 times pi over 10 cos omega t, which is 3.5 times with the t plus pi naught. Then theta t is equal to when you press the calculator, we will get that 0.35 pi cos 3.5 t plus pi naught. Okay, now we substitute t with 0. So theta single dot at the time 0 is equal to 0.35 cos 3.5 times 0 plus pi naught. So here we will get that theta dot single dot is equal to 0.35 cos pi naught, and at the same time it is equal to 0, right? Now we can find pi naught. So here we find that 0.35 cos pi naught is equal to 0. So cos pi naught, we move on to the right side, we still get 0. Here, as you can see with 0, that means that the phi naught is maybe at the condition at the first quadrant or at the fourth quadrant. So pi naught is equal to pi over 2 radian at the first quadrant, and this fourth quadrant we get that pi naught is equal to 3 pi over 2 radian. So it means that here we have the first condition and the we have the first and the fourth quadrant at the cos program. Alright, so here the first, and here we have the first two quadrant. So that means that we can make a conclusion that since sine pi naught is more than 1 and cos pi naught is equal to 0, thus pi naught is equal to pi over 2 radian. Alright, so confirm that pi naught is equal to pi over 2 radian. So thus that theta, or angular displacement as a function of time, is equal to a sine omega t, right? A sine omega t, which is a is equal to theta max, which is pi over 10 sine, and then omega, which is 3.5 t, plus with the pi naught, which is pi over 2. And here is the final answer. Alright, that is all. I hope you understand what I'm teaching. So if there is a question, please refer to me again. Thank you and have a nice day. Goodbye.